Hopefully I'll have one of these. I want to look at the coffee pot problem first. We've got a lot of work to do, so I'm not going to do the coffee pot problem for you. It's almost identical to the one in your textbook as example one. These differential equations, this is chapter 7.3, right? Other real world applications. Example 1 in 7.3 is a problem. It talks about leaking. This is almost the exact same problem. You can look at that. One of the things I want to point out, however, is when you look at part B, right? They have this differential equation. A dH dt is negative square roots of h over 5. You're supposed to solve the equation as a function of t, given the fact that h is 17 when t is 0. So that's your initial condition. And the combination of this differential equation or any differential equation and a condition is called an initial value problem. So you'll hear me say that, initial value problem. It means I give you a differential equation, I give you a point, and you have to find the equation. We did some yesterday with exponentials. None of these four are exponentials. Okay, so these are other type problems like 7.3. The other thing I mentioned on the solution of these things, remember the first step was to do what? You wrote it down yesterday. Step 1, separate the variables. So I scanned in here this is the rubric. These free response problems are worth 9 points, 9 points total. And for this problem, here's part B. Here's the solution. This is how it will work. You can look at this. I'll put this in on your class page so you can see it. But notice that there's 5 points total, part B, and 0 of 5 if you don't separate the variables. You get no credit, even if you do everything else. 0 of 5 if you don't separate. Because that's the first thing you got to do. You get a couple points for the antiderivatives, or you get 1 point for the antiderivative, you get 1 point for the constant, and then notice this, the max you can get is 2 out of 5 if you don't put in plus C. You know what? Where's the C? Where's the C? You don't do the C, you don't get the credit. The max you could get is 2 out of 5. Okay, so when we work through these problems, and we're going to do the three that are on this sheet, right, other than the coffee pot problem, I want you to think, separate, that's the first step, find the antiderivative, integrate both sides, throw in a constant, use the conditions, try to figure out what the constant is, and then solve for y. In this case, it says solve for h because the differential equation is with h. But all of these are going to be worked that way. Now, with that in mind, when we have these diffie-q's, what's a diffie-q? A differential equation. So when we have these differential equations, these diffie-q's, you have a algebraic or an analytic approach. This will give you the exact answer, exact solution. And that's what we're going to do today, right? And that involves separate and then integrate, right? Throw in the constant, etc. All the stuff we did yesterday, we'll do that today. But there's also 2 other methods of solving these. And these are approximations. So for these differential equations, you also in this chapter, you'll learn to approximate APPROXI, approximate solution methods. I might as well give you their names. You'll see them in these problems. So in 3 of these problems, you see little dots, right, and it says draw a slope field. We're not going to do that today, but I think it's sort of fun. Slope fields are both an A, B, and BC topic, so I mean, everybody does them. And the other approximate method is something called Euler's method. And both of these are in your book. Okay, I think this is 7.4 and this is 7.5, or maybe 7.5 and 7.6, but they're in this chapter. And we will learn how to do slope fields and how to do Euler's method. But for today, I really want to focus on this analytic approach, get the exact solution by separating and integrating. Okay, so let's go. It's on the other side from the problem. So turn it over. It says number 6. It says dx is equal to minus 2x over y. Everybody see that problem? Part A says on the axis provided it's a slope field. We're not going to do that. Part B says y is f of x is a particular solution. That's going to be the answer. We've got to come up with y. Oh, actually, we're going to skip part B, too. Part B talks about write the equation for a tangent line. Okay, we don't need that. We're going to do part C. It says find particular solution, y is f of x, to this given differential equation with the initial condition f of 1 is negative 1. Okay, so that's what we're going to do. We're going to do part C. If we look at the grading rubrics, if this whole thing is worth 9, there's probably 5 of the 9 are on this. Most of the credit is separate, integrate, put the C in, use the condition, find y. Okay? Now, remember the separate, you get all the y's on one side and all the x's on the other. Okay, so this y is going to go up here. Right? So we get y dy, and this dx is going to go over here. So we get minus 2x dx. That's the separate stage. You have to write that down. All the x's are on one side, all the y's on the other. If you don't get that, 0. No, go to the next one. Second step. Now that doesn't mean just draw a squiggle. That's not integrating. That's drawing a squiggle. Integrating means finding the antiderivatives. Right? So you should draw a squiggle, yes. But what is the integral of y dy? Y squared over 2, right? Y squared over 2, using the power rule. Yeah? And what's the integral of minus 2x dx? Minus 2x squared over 2, which would be minus x squared, right? Minus x squared. Yes? Let's see. Right, because if you don't write the C, you're gonna lose 60% of the credit. A max you could get would be 2 out of 5 if you don't write that plus C. Okay, you got to do that. So far, so good. We talked about this yesterday. We talked about it yesterday. There's a C1 here and a C2 there. C2 minus C1 is safe. Just put on. We want to leave the y. By the way, what's the next step? Solve for y. We're trying to get the y. Now, we should be able to put this initial condition in. I'm not going to do that at this stage. I'm going to solve for y first. It shouldn't matter, but I'll show you why I want to solve for y here. What would I do for y? Any ideas? Multiply by 2. Okay, so I can do that. I have y squared is, and I'm just going to write it this way right now. And I suppose I can distribute that if I want. What's the next thing? Take the square root of both sides, yes? Everybody, plus or minus? Okay, so y is going to be plus or minus the square root of 2 times minus x squared plus c. Now, how do you choose? It's almost like the absolute value deal that we talked about yesterday. This says plus or minus. What was our condition? Our condition was that if you put 1 in, you have to get out a negative 1. Do you want the positive root or the negative root? The negative root. Y has to be negative. It says y is negative, right? Y has to be negative. So we want, in this case, not plus or minus, but simply the minus. That's what we want, minus. Okay? And that's going to depend on the condition. If the condition was something else, if f of 1 was 5, then this would be a positive square root. Okay. Let's go ahead and chase down what the constant is. Now, remember, we were told that f of 1 was supposed to be minus 1. Let's see if you can do that. Put those values in for x and for y, and see if you can find c. It's not terribly hard. See if you can do that. And once you have that finished, then you will have this is the general solution, right? This is general because you don't know what c is. But once you get c, you're going to have the particular solution. Particular solution. And that's what you need for this problem. So put all the numbers in, do the arithmetic. Just be careful with your order of operations and your signs. Okay, so if all my arithmetic is right, let's see, I put -1 right here, right? So y is -1. And for x, I put in 1. So I put that in right there. Now remember what this says. This is a common mistake. I think I started the year this way. Can you tell me what number that is? -9, right? It's the opposite of 3 squared. Can you tell me whether this is positive or negative? Always negative. It's the opposite of something squared, right? Always negative. So when I see this, -1 squared, I know that is a negative number. So when you put the x's 1 in there, that becomes -1 because we're squaring the 1, right? And then the rest of it's pretty straightforward, right? By the way, from here to here, I just multiply through by -1 to make them positive. And then from here to here, I squared both sides. That, square that, right? Yes? Okay, so C works out to 3/2. Now, the interesting thing, on problems like this, if you separate, you get a point. If you integrate both sides, you get another point. If you write a C, you get another point. So you're 60% of the way there. It's the last couple of points that are hard to do, right? So you got to get, maybe you made a mistake, and you might lose that. And you have to put in your specific solution. The specific solution here, let's see, C was 3/2, yeah? Okay, so let me just chuck that right in there. And I'll just go ahead and verify that everything works right. Let's see. Y is equal to -√2 times -x² plus 3/2. Right, that's my particular solution. I'll clean that up a little bit. I don't have to, but I will because the 2's sort of cancel there. So I get the square root of -x² over 2 plus 3. So that's my solution. Now, just so that we're not, fooling ourselves, let's make sure that this condition works If I put 1 into this function, I should get -1 out. Do I? Let's see. If I put 1 right there, yeah, so if I tried to put the point in, it wouldn't have worked, right? I'm going, well, where did I go wrong? Thank you. Negative? Yes. Square root? Yes. -2x squared plus 3. Yes? Thank you. What can I do? Well, those are, if you had C and 2C, those are not the same. But if you had C1 is the same as 2C2, I mean, or C2 is the same as 2C1, you could do that. It's probably better just to leave C alone all the way down and figure out what C is and then put it back in. Let's make sure the point fits. What is y of 1? Well, you'd put 1 right here. Does that work? Yeah, y of 1 is -1. Right, it's the square root of 1, which is 1. Okay, so that works. And let's find the derivative. Let's see, the derivative of this guy, dy dx. The derivative, that's a square root function. The derivative of square roots are 1 over 2 square roots, right? So that's from there. 2 square roots is here, minus 2x squared plus 3. But then you have to use the chain rule. Got to take the derivative of the inside, which is -4x. -4x, like that? Okay, so this derivative, dy dx, you don't have to do any of this, it's just sort of checking to make sure it works, is supposed to be, well, let's see, the negatives cancel. 2 goes into 4 a couple times, so I get 2x over the square root of -2x squared plus 3. Okay, so that's my derivative. What was it in the original problem? In the original problem, this derivative is supposed to be, let me put a question mark here, is this really the same as -2x over y? Is it? Well, there's the 2x. And if you put a negative down here, isn't that y? Yeah. So it works. I mean, we have the right derivative and we have the right functional value. Okay. Everybody happy with that one? No exponentials here. Just plain old power. Okay, let's go to the one below that. This is dy dx. Oh, I lied to you. This one is an exponential. 1 plus y over x. Right? X is not 0. And it says find the particular solution. Y is f of x. We're going to try to get that. And here's the condition. F of -1 is 1 this time. Okay? And then it talks about stating the domain. Maybe we can do that. I think that was only worth 1 to 9 points. First step. First step. You have to separate. You have to get all the x's on one side and all the y's on the other. You don't do that, they just throw it. Okay, so try to separate. Now, I will tell you, you want the dy's and dx's on the top. You want those on the top. You're never going to throw those on the bottom. Okay? So this dx is going to go there, right? And this sum is going to go down here. And that's the only way you can do it. So you have dy over 1 plus y, and this is 1 over x dx. You could write dx over x. Okay. Now, the more of these you see and the more of these you practice, it will get easier and easier. Comments on separating? Okay, this is pretty much the only way you can do that. If you tried some other algebra stuff, you would not get the x's and y's separated. This is the only way to do it. If you go down other roads, you're going to end up in dead ends. So you got to go back to this. This is the way to do it. Okay, so the next step is to integrate, like this and like this. Right? And the right side's pretty easy. Natural log, absolute value of x. And in this case, it's really important to have the absolute value of x. Look, x is supposed to be -1. You know, the absolute value of -1 is undefined, but the absolute value, I'm sorry, the log of -1 is undefined, but the log of the absolute value of -1 is fine. Okay, so you got to have that. How about on the right side? Well, let's see. Think of it like this. We have the integral of 1 over 1 plus y dy, like this. That's what we have. And if you go back and look at your integration rule, there was an integration rule that said if you've got the integral of 1 over ugly d ugly, that was the natural log of the absolute value of ugly, right? Plus a constant. Well, we're going to put the constant on the right. Isn't this ugly? Not that terribly. What's the derivative of that thing? 1 dy, right? If this is u, if 1 plus y is u, then du dy is 1, and du by itself is dy. So yeah, so this is fine. And everything's set up perfectly. We don't have to do anything. We just integrate it, and we get a log of the value of 1 plus y, right? Pretty good so far? Okay. Now, what's the next step? Well, you can do two things. We're going to get y by itself, right? Solve for y, right? We also have to take this guy into account, right? We have to use this condition somehow. I think sort of following along with what we did yesterday, it might make sense to talk about the absolute value. Can we throw those away? What is y for this problem? Y is 1, right? There it is. Y is 1. Do I need absolute values? No. So right off the bat, I would write this as okay. We got to get the y by itself sooner or later. Notice we do absolutely need these over here. We don't want to make that go away yet. Can we solve for y? I suppose we could solve for y. We can also get c. I mean, there's a number of ways you can go here. Let me try to chase down what c is. We know that if x is -1, y is 1. That's what this says, right? If x is -1, y is 1. So if we put that in here, what do we get? We get the natural log of 2 is, right, because we're putting -1 in here, right? So that's the natural log absolute value of -1, which is the natural log of 1, which is 0. So we get c right off the bat. So in this case, it's pretty easy to get c, and I'll go ahead and throw that in immediately. Okay, so now we have y is the natural log absolute value of x plus the natural log of 2, like that. Yeah? Holler up if you don't like something. Okay, somewhere along the way, if you look at the directions, it says find y equals. So we've got to solve this for y. Yeah? Now, on the right side, I do have log plus log. Can I clean that up at all? Properties of logs from algebra? Log plus log. So how could I rewrite the right side? Natural log of 2 absolute values of x, like that, yeah? Do you have to do that? I don't think you do. It would probably work fine to do it this way, but I think that's where I want to go. You might want to try it without combining those. How do I get y by itself? What do I have to do? Exponentiate both sides, right? So I get 1 plus y is e to the natural log of 2 absolute value of x. Right? But that's simply 2 absolute value of x. Yeah, so that goes pretty quick. 2 absolute value of x. So y is equal to 2 absolute value of x minus 1. Okay. Again, I think it's probably a good idea just to check and see whether or not this differential equation at the very, very beginning makes sense, right? Because it's supposed to be, if you take the derivative, you're supposed to get that. And let's see if that's the case. First of all, we were told that y of -1 was supposed to be 1. Does that work if you plug that in? If you put -1 in for x? Okay, so that works, right? The condition is good. So we know that part's okay. Let's take the derivative. Okay, so now you're sort of running into a, golly gee whiz, I've never had a derivative of absolute values before. Okay, so maybe we can think, what does the absolute value mean? And you can think 2 ways. You can look at a picture, right? Here's the picture of the graph. Yeah. Okay, and we're talking about the slope, the derivative, the rate of change. What's the derivative over here? -1, right? And over here, +1. And here, not 0. Fine, you can't get derivatives at corners, right? So, but the good thing is, we don't care about x is 0. Which side of this graph are we looking at? We're looking at, what were we putting in for x? We're looking for this side, aren't we? Yeah, because x is negative, right? X is negative wherever we had that, right here. We're talking about the left side of this graph. Okay, so the derivative is simply going to be -1. Yeah. Okay, so let's go ahead and take the derivative. dy dx is going to be 2 times -1, right? -2. dy dx is -2. That's our derivative. And somehow that's supposed to be the same as what? 1 plus y over x. So let me, is this the same as 1 plus y over x? That's the question. Okay, well here's y, yes? So if we add 1 to that, we get what? If we add 1 to this, 2 absolute value of x. That's what this is. 2 absolute value of x. And now we have to divide. I don't like that absolute value. What do I replace? Now again, a little thinking here. What is the absolute value of x going to be for this problem? Like, why is it negative x? Because x is negative, right? Isn't that, we talked about that yesterday, right? We had said that the absolute value of x will be x if x is bigger than 0, and the opposite of x if x is less than 0. And we certainly know x is less than 0, so sure, I can replace that with -x. And now, does it work? Yes? Is this true or false? Somebody tell me it's true. Oh, good, it's true. We've done the problem right. Okay. Right, because the x's cancel and you get -2 is -2. So everything works hunky-dory. Okay. Turn the page. I'm going to let you work on this one by yourself just for a little bit, and then we'll see if we can get good answers out of it. We've got x times y minus 1 squared, and for this problem, f of 0 is -1. Okay, so if I were to give you 5 minutes to do as much work as you can, jump on it. Separate, integrate, throw a c in there, try to figure out what c is. Do all those steps. If you didn't get to that, everything after you is wrong. So you have to get to that of some form or another. Okay, so make sure you get that first. Then go ahead and do the integration. That'll be nice. I'll do half the problem for you. Do the other half. Go. Yeah, it was in the denominator, wasn't it? Negative exponents are in the denominator. Right? I mean, the power rule we have, the only power rule we've got is u raised to a power, du. Right? It has to be that. It's not a natural log. A natural log has to be 1 over ugly d ugly. And if you're considering this as y minus 1 squared, which you could do, you would have to have somewhere over here 2 times y minus 1 dy. And you don't. And you can't get it. It's just a power rule. Okay. Now, the good news is you might get 2 out of the 5 points. You separate it and you throw a c in there. But yeah, if you can't integrate this, or this is the integration that you're doing, if you can't get that, then you're sort of out of luck to get full credit. Right here. Mm-hmm. And y is -1, so it's -1 over -2, which is 1/2, right? Sort of deja vu back to 8th grade when you're doing all this sign number arithmetic, you know. Like, oh yeah. -1. So I'll tell you a little story. When I first started teaching, I was using this book as a geometry book. And it had a number of theorems on proportion. So read proportion theorem 2 out loud. What does it say? First of all, what's the name of this theorem? The upside downable theorem. What does it say? Could you do it in symbols? So what did they do to the two ratios? Just turn them upside down, right? It's the upside, I saw that name, the upside downable theorem. That's sort of the coolest thing I've ever heard. Why do I want that here? It actually makes things a little bit easier. Remember, we're supposed to solve for y. So if you do the upside downable theorem, you get y minus 1 over -1 is 2 over x squared plus 1. Yeah. Maybe multiply both sides of this equation by -1. So you get this. And then finally get y by itself. Add 1. That's it. Now, a lot of algebra there. I will tell you that very, very few people get 9 out of 9 points on these. You do not have to get it perfect. You have to get most of the points. You're going to get most of the points by separating and integrating, trying to figure out what c is. Trying to get the y by itself at the end can be hard. If you've got plenty of time, go back and go through all of this. You know, there's a lot of work here trying to get from this. I would suspect that somebody gets here or something similar to that. Good. I mean, if you have good algebra skills, you can get there. By the way, if you get a common denominator, this would be x squared minus 1 because it's right. So x squared minus 1. That's also the same thing. Right? Anybody get there? Other than Ivy? Okay. Don't lose any. I can't get it exact. That's okay. Just realize there will be algebra. Right? There will be. Okay. Since we've got a little bit of time, I do want to look at slope fields today. You've got 3 different examples of slope fields. And let's go to number 5, the one that has the little tiny graph down there on the bottom. This is where dy dx is 1 plus y over x. And they give you a grid, and they have 8 dots. This is at 1 and 2, and 1 and -1, and -1 and -2. And at each one of these locations, there is a point that's plotted here, 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 here. And say the slope field at 8 points indicated, right? Draw the slope field. What the heck is a slope field? A slope field is a little tiny line segment. I'll do it in green. It's a little tiny line segment angled that shows the slope. So this would be a slope of 0, right? If it were a 45-degree line, that would be a slope of 1, right? If it were going the other way, that would be a slope of -1, right? You know what slopes mean, yeah? A slope of 2 would be steeper than this. It would go like up 2 and over 1, so it might look something like that, right? The slope of -2 would be steeper going down like that. So those are the idea. Slope of a half. You know, what does a half look like? A slope of a half might look like that, right, where it goes up 1 over 2. Okay, so what you're supposed to do is to calculate the slope at each one of these points. Everywhere there's a dot, you're going to draw a little line. Where do you get the slope from? dy, that's the slope. Okay? So let's choose this one for an example. The ordered pair here is 1, 1. If you put those numbers in, what do you get? 2. So what you're supposed to do here is draw a little line segment that has a slope of 2. Now, they are not going to take a protractor and measure it, right? It's supposed to be 2. Technically, if you were to continue on, it should probably come all the way down to here, right? Because it's supposed to go up 2 and over 1. But as long as you have a little line segment there, that's fine. Okay, let's do this guy here. This is the ordered pair 1, 0. And if we put that in, we get 1, right? So at this stage, you just draw a little line segment like that. Now again, we're not going to take an angle measure and make sure that it's exactly right. They do have to see, however, that this line is steeper than that one, because this has a slope of 2 and this has a slope of 1. Okay, see if you can do the other 6. Do the other 6. And 2 of them are super easy, right? Okay, here's your solution. Notice that for this particular, this is worth 9 points. All these are worth 9 points each. 6 of the points were over here, right? Doing the separate, and got 2 for the antiderivatives, constant, solving for y. 2 of the 9 points was drawing the picture. They just gave you 2 points. Don't spend a lot of time on it. It says the sign of the slope at each point has to be correct. These have got to have positive slopes. These have got to have negative slopes. And relative steepness of slope lines in rows and columns. In other words, that these have got to be steeper than these, right? And these have got to be shallower than these. And these are the easy ones, because if y was -1, slopes had to be 0. So a couple of points for just drawing the little line segments. And then this is what we did before, right? Separate, integrate, and they go through the whole solution here. I don't know that we need to go through this whole thing, but there was the absolute value. Okay. Okay, let's do another one. Let's do the one on the same page above that. So, dy dx, the slope is negative 2x over y. And you've got points to do. 12 points. This must be impossible. I don't have time to do 12 points. Can you give me some points that are going to be like super easy to do? Because I've got one here. Right? Every time x is 0, what's the slope going to be? 0. Okay, so for these 4, right off the bat, you've got zip, 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 zip. Right? Easy. If x is 0, you're done. The other ones you have to deal with are these guys over here. Let's see, this is 1, 2. And they have these couple of dots. See if you can find the slopes there. And then these couple of dots. Find the slopes there. Oftentimes, these slope fields are very symmetrical. Right? They have a nice little pattern to them. While you're doing that, I'll pull up the solution for this guy. 2005. There you go. By the way, do these pictures remind you of anything that you might have seen in middle school science class? The magnetic filings, right, where they take a piece of paper and they tap it. This is an ellipse, by the way. Okay, this is an ellipse. It was worth a couple of points. You get 1 point for the 0 slopes, these guys, and you get 1 point for the non-zero slopes. Notice I didn't give you part B. You didn't have to worry about that. But for part C, it was worth 5 points, right? Separate, antiderivatives, constant. Okay. Take a look at your page. I think I'm going to send you a couple of other free response questions I want you to play with. Have a good weekend. I will.